Welcome to the ET322 how-to video for the MOSFET motor driver lab. We're going to build it in Multisim. Okay, so let's get started building our MOSFET driver in Multisim. So let's go to basic here. Basic. And let's go to switch. And we're going to get a single pole. Let's get a double throw, and that way we could drive it both directions, because we're going to need a ground and a positive voltage. Alright, so let's go back to transistors. We're going to go MOSFET enhanced in channel IRF 510, and we're going to need a ground. Go to sources. Let's get a VCC. We're going to make it positive 12 volts. And let's go to our indicators, and we're going to make a fake motor here since there isn't a very good one. So we're going to use a voltmeter lamp bar graph. Okay, and that should be good. We're going to use him as a motor, so we're going to double click on him, and when he's at 12 volts we're going to have our maximum light, and this is just on and off on the first lab. So let's go ahead and zoom in. Oops. Zoom area, and let's put it together. So we're going to, let's go ahead and I'm going to rotate this guy horizontally. And what I'm going to do is I'm going to put a ground on one end. And this is our space key, and we're going to run up over and this guy's going to go to our gate, and we're going to need 2 grounds. This is going to go to our output. And let's redo this. So let's get rid of that. What we're going to do is this guy's going to be in our circuit. So when we provide a ground, let's go ahead and rotate that guy. Yeah, that looks a little better. Okay, so let's make this 12 volts. And we have our circuit. Here I've created a starter file for the MOSFET motor driver. What I've done here is simulated a motor. Here's a motor, a conversion, and a voltmeter. So it's going to give us a relative value at motor speed. This would be the load on the motor. And I've got the IRF 510, and I got a replacement for the IRF 9510. So this device has the same characteristics as the P-channel MOSFET. Here I have the master, and I've saved it as something different so I don't lose all the components. So let's get rid of our P-channel for now, and let's build part 2. So we have our MOSFET down here, and this MOSFET is going to provide the ground for our motor. Okay, this time we're going to use pulse width modulation in order to drive the speed of the motor. So let's go ahead and get some power supplies. Go sources, power sources. We're going to need, let's use VCC because we're going to need 12 volts. And we're going to need a signal generator, and we're going to use a clock voltage. We're going to use a DC TTL type signal. And that's going to go directly into our MOSFET, which is a voltage controlled device, unlike our bipolars, which are current controlled devices. And we're going to need an oscilloscope. And let's go ahead and just use a standard one. So we're going to look at our pulse, and eventually we're going to come back in and take a look at our loading on the motor. But we're going to have to do some modifications because this motor will block out some of the signal. So this will get us started. Okay. For part 3, instead of using our complicated motor circuit, let's just go ahead and use our light. So let's build it from scratch. So let's get our transistor. Oops. And we're going to use our MOSFET enhancement ATP. This guy needs to be flipped vertically so that we have the source on the bottom, drain on the top. Source on the top, drain on the bottoms. Okay, so let's go ahead and get our indicator bar graph. Okay, and we need a switch. Go back to basic switch, SPDTT, because we're going to use both. Let's flip him horizontal so we get the pins in the right place, and we're going to use a 12 volt VCC. So let's go to source, power, VCC, and we need a ground. Alrighty, so let's copy our grounds. And let's go over here to our switch. Let's convert that to 12. And let's slide our motor in there, and we're going to use a positive voltage, so we're going to use our ground over here. And we're going to have our gate go here, and that looks done. Okay, let's build part 3, the CMOS inverter. So we're going to need both transistors. So let's go to our transistors, and we're going to use our P channel. He's going to be on the top, and let's see, do we need to swap him? And yes, we do. So let's go ahead and flip him horizontally. Let's go get our 39 IRF 510, our N channel, and let's flip him vertically, horizontally, so that we have our, and we're going to need 2 510 resistors, make it 4 510s. One. Okay, and there's 4, and we're going to need a 1K. And all of these need to be rotated. Okay, so we're going to need a red and a red and a green LED. Okay, and we need our switch. And again, we're going to flip this guy horizontally. All right. Let's zoom in at a ways. Alrighty, let's build it. So we got 2 510s in between here. Good. And we're going to have a ground. Did I forget the ground? I did. So let's go back and get a ground. Let's grab another one. Okay. And our LED, our green one is pointing down. Our red one is pointing down. And we have current reducing resistors. Okay, and good. So we're going to need to place a junction here. That way we could connect these two. Oh, come on. Okay. And we have a ground down here. And we have our 1K. So our switch doesn't have a problem here. And switch. Oops. Oops. This is providing our gate voltage. Okay, so we need 5 volts. Let's go ahead and just use separate ones. Yeah, these could be all tied together, but let's go ahead and just do it this way. Alright, so we have all of our power now. We need another ground. And that looks good. Whoops, we need another ground. Okay.